In this video, we are going to talk about how to write quadratic equations when we are given the solutions. So just a few kind of things to remember. Back in Outcome 2, we learned that factored form looks like this here. We have our a value out front, and then in parentheses, we have x minus these numbers. Those numbers there that you see represent the x-intercepts of the graph. So in this lesson, we're going to work backwards. We're going to take our solutions, write them first in factored form, so like this first thing that we have highlighted, and then we're going to try and get it back into standard form. So example 1 starts off with asking me to write a quadratic in standard form. So that means that my answer should end up looking like y equals ax squared plus bx plus c. Based on this graph here, I can find my solutions. Solutions are another word for x-intercept. So looking at my graph, I see that it crosses the x-intercept twice. Looks like it crosses at -3 and at -5. Now the first thing that I'm going to do is write this in factored form. So I'm looking back up at the top here. I have a y equals, and then I'm going to jump into my parentheses. I know that both of my parentheses should start with an x, and what I want to do is take this solution and flip the sign. Remember that in parentheses, the sign is always opposite. So I have x plus 3, and I have x plus 5. Just a little side note here, if that part was confusing to you, every time that we've factored, we always wrote our answers as x equals the number, so x equals -3. What we're doing here is just bringing it back to the same side. So to move that -3 over, I would have to add. So now I have x plus 3 equals 0. This x plus 3 is what's going into my factor. From here, I'm trying to get this into standard form, so I'm going to distribute. So x times x gives me x squared. X times 5 is 5x. 3 times x is 3x, and 3 times 5 is 15. Last step is to combine like terms. I have 5x and 3x, so I'm going to leave this as y equals x squared. 5 plus 3 gives me 8x, and I still have that constant of 15 on the end. A few things that you want to check for. It does say that this needs to be an equation, so make sure you have a y equals here. I do have a y equals, so I hit that box. And then it also wants it to be in standard form, which is my ax squared plus bx plus c. It looks like I have that. So I am all set for this first example. Okay, let's do a few more together just to make sure that we got it. So example 2, again, says write a quadratic in standard form. And I do want to add on here that this should be a quadratic equation. A little bit different this time. It does not give me a graph. Instead, it just gives me those solutions. So that's like this first step that I had up here. Once I have my solutions, again, I can jump right into that factored form. So I'm going to start this as y equals. And I have my parentheses. First solution is a 0. So if you want to, you could write this as a plus 0, a minus 0. Doesn't really matter what sign you put there because adding and subtracting 0 doesn't change anything. Next, I have a positive 3, which I'm going to switch the sign and make it a -3. Now this one's a little tricky because of that 0. We just said that adding and subtracting 0 doesn't change anything, so I'm just going to change this entire parenthesis to just be x. Adding 0, subtracting 0 doesn't even matter, so I really just have an x there with an x minus 3. Again, I can distribute, so x times x gives me x squared. X times -3 is negative 3x. I don't have any like terms here, so this is my final answer. Example 3 gives me 1 and negative 3/4. So this is the first one we're seeing with a fraction. Now, the 1 we should know how to do, so I'm going to start with that one. I have my y equals, and when I go to put it in the parenthesis, the sign changes, so it's now a -1. But this fraction is kind of different. I don't want to put it just right into the parentheses. Like if I wrote it as x plus 3/4, I'm then going to have to like distribute. Sorry about that, 3. I'm then going to have to distribute with fractions. We don't like fractions. We try to avoid them. So how can I change this here? Well, the issue is that we're dividing by 4. The opposite of dividing is multiplying. So I'm going to write this as 4x. That denominator just jumps in front of the x. Then I'm adding the 3. I personally like to always use this shortcut. We kind of saw it when we were factoring, that denominator going in front of the x. If that was confusing to you, you can do a little bit of side work here. Whoops. By taking your fraction, setting it equal to x, and then just trying to get this right-hand side to become 0. So I would start with multiplying by 4 to get rid of that denominator. So I have 4x equals negative 3. From there, to move the negative 3 over, I would add. So I have 4x plus 3 equals 0. Whether you use the shortcut or you show your work off to the side, does not matter, as long as you end up getting 4x plus 3. Okay, from here I'm going to distribute again. So x times 4x is 4x squared. X times 3 is 3x. Negative 1 times 4 is negative 4x. And negative 1 times 3 is negative 3. Again, I'm going to look for like terms. In this case, I have 3x minus 4x. That becomes just a negative x. And I'm dropping that minus 3. Checking for those two things, I do have a y equals, so this is an equation, and it does look like it's in standard form, so I am all set. Okay, the only way we can make this a little bit different is to give you imaginary numbers as your solutions. What's nice about this is that process does stay the same, and you're going to see kind of some cool things happen with these i's. So I'm going to start again with writing it as y equals. Now, I know it seems weird that we have i's there, but the same process holds true where when I put this in parentheses, I want to change the sign. So because this is a positive 2i, I'm going to make it a minus 2i. The next one, since it's a negative 2i, I'll make it a plus 2i. Okay, we're going to go ahead and distribute, and things are going to get a little ugly here, but trust me, some cool things will happen in the end. So x times x is x squared. Next part's weird. X times 2i. Now this is strange because I have kind of two letters there. I have an I and an X. I'm going to write this as plus 2 first, since 1 times 2 is 2. Then I'll put the I and then the X. Technically, the order doesn't matter since we're multiplying here. Whatever order you choose, I recommend that you keep it consistent. Next part is negative 2i times x. So I have a negative 2, an I, and an x. And the last part, I have negative 2i times 2i. Negative 2 times positive 2 is negative 4. And I times I is I squared. Now I know this doesn't look very nice right now, but hopefully you notice that in the middle here I have like terms. Both of these have i's and x's, so I can go ahead and combine them, and a positive 2i minus 2i actually just cancels right out. I can also do some work here with this I squared. We've always said that I squared is equal to -1, so I'm going to cross off that I squared, change it into a -1. From here, that -1 is multiplying with the -4. So my x squared isn't changing, but a -4 times a -1 makes this a +4. At this point, I would look for like terms. It doesn't look like I have any. I am in standard form, so this is my final answer. I do want to make just a little side note here, is that you should have no i's in your final equation. Every time that we write these in standard form, these middle two values should always, always, always cancel out, and this I squared should always be changed to -1. You will never end up with an I squared in that final answer. Okay, on the next page, we have a bunch of them for you guys to try. I'm going to go through number 8, since it has i's again, and number 9, since it has fractions. If you're feeling confident, I recommend that you pause your video, try 8 and 9 on your own, and then you can come back, press play, and check your answers. So number 8, I'm going to start with putting this into factored form. I have a positive 8i, which in parentheses becomes a negative. And then I have a negative 8i, which becomes positive when I put it in parentheses. I'm going to start distributing here. X times x is x squared. X times 8i is a positive 8ix. Negative 8i times x is negative 8ix. And negative 8i times positive 8i. Negative 8 times positive 8 is negative 64. And I times I is I squared. Again, I'm noticing in the middle here that this 8i and negative 8i cancel right out. I can also change my I squared to be a -1. So I still have y equals, still have that x squared, but now this -1 and negative 64 are multiplying together, giving me a positive 64. Here's my final answer. It's an equation because it has a y equals, and it looks like it's in standard form. Okay, one more, number 9, 2 fractions this time, so a little bit trickier. I'm going to start with jumping right to my factors or my parentheses. Now the first one it gives me is -3/2. We said that the denominator goes with your x, so 2x. The numerator will go behind it, and I still need to flip that sign. So right now it's a negative. I'm going to make it a positive. Next one was 1/3. So again, denominator goes with x, so I have 3x. 1 will go after it since that's the numerator. And I'm going to change the sign, making it negative. Again, remember, you can always set x equal to those. So x equals -3/2 and solve. So I would multiply by 2. So 2x equals -3. Adding that 3 over still gives me 2x plus 3. Okay, now that I'm in factored form, I can go ahead and distribute. 2x times 3x gives me 6. Whoa. X squared 2x times negative 1 is negative 2x. 3 times 3x is 9x. And 3 times negative 3 is negative 3. Combining like terms here, in the middle I see a negative 2x and a 9. Negative 2 plus 9 gives me a positive 7x. I'm leaving the 6x squared and the minus 3. This right here is my final answer. It's an equation because it has that equal sign, and it looks like it's in standard form.